This lesson is about factoring trinomials, and in addition to solving equations and graphing, I think factoring trinomials is the most important thing you're going to learn in this course. Standard form of a trinomial is ax squared plus bx plus c, and what we're trying to do is factor that back into two binomials. And it's really helpful if you remember what happened when we multiplied the binomials together, since we're trying to work backwards. Remember foiling, and we got these four terms: x squared, 2x plus 3x, and 6. And of course, to make the trinomial, we had to combine the two middle terms. So our job here is to take this 5 and this 6 and turn them back into a 2 and a 3. And I like to use what's called the diamond method because it gives you a visual organizer. You just draw a diamond. Looks like an X, but we'll call it a diamond. And in the upper region, you put C, whatever your last number is. In this case, is 6. And underneath, you put B, the middle coefficient, which is 5. And then in the two open places, we want to figure out what those two numbers are that multiply together to give us the 6 and add together to give us the 5. Or, using correct terminology, two numbers that have a product of 6 and a sum of 5. So one way to do it is just to think about it and know it because you're so good at your multiplication facts. But if you're not sure, if you can't think of the numbers right away, make a list of the factors of C. There are only two ways we can multiply two numbers to get 6. 1 times 6 and 2 times 3. Which of those options adds up to 5? 2 and 3. So we put them in there, and then we have our solution. X plus 2 times x plus 3. Isn't that fun? Solving a mystery. All right, let's do an example. X squared minus x minus 12. So I'm going to draw the diamond. I'm going to put the negative 12 in the top. Make sure that you bring along the sign that precedes the number. And negative 1 in the bottom. So if there's no number in front of the variable, it's a 1. And a trick that you can use is if you have a 1 in the bottom, that means that your two numbers have to be consecutive, because in this case, when we subtract them, we just get negative 1. So thinking of the factors of 12, we have 1 times 12, 2 times 6, and 3 times 4. And I highly recommend that you make an organized list of the factors. That way you don't have to keep trying things over and over and forgetting which ones you already tried. You just know that it has to be one of these three, and if it's not, then the trinomial isn't factorable. So which of these two possibilities could add up to a negative 1? Well, 3 and 4. We'll put the 4 and the 3 in our diamond. And since they have to multiply to make a negative 12 and add up to a negative 1, we need to make one of the numbers negative. And if you think about it, it needs to be the 4 that's negative, because negative 4 and 3 gives you the negative 1. And there is our answer. We did it. Here's a tricky one. X squared plus 8x plus 8. What's happening here is that B and C are equal to each other. So can you think of a pair of numbers that both adds to 8 and multiplies to 8? Well, our factors are 1 times 8 and 2 times 4. Does either of those add up to 8? No. So this trinomial is not factorable. In fact, anytime you have a trinomial where B is equal to C, it will not be factorable. So that's a shortcut that you can remember. There is one exception though. Can you think of a number that if you add it to itself, you get the same thing as if you multiply it by itself? Did you think of 2? That's right. X squared plus 4x plus 4 is the only case where you have a factorable trinomial where B and C are the same number. And in fact, that's one of the perfect squares. It's x plus 2 squared. And we'll learn about factoring those guys as a special case later on. Okay, here's an example where there's a GCF in common between all three of the terms. We have a 2, and in fact, we've got an x squared, and there's our 2 and an x squared, and another 2 and an x squared that we can pull out. If you neglect to take out the GCF, you're going to make the problem a lot more difficult and maybe even impossible. So make sure that you pull out, in this case, the 2x squared. That leaves us with x squared minus 7x minus 18, and that will be a lot easier to factor. The 2x squared is just going to sit there, but be sure you don't forget to include it in your final answer. So now we need to factor this guy. So let's make our diamond. We've got negative 18 on the top, negative 7 on the bottom. So let's see. I'm just going to look at the factors of 18. We've got 1 times 18, 2 times 9, and 3 times 6. It's a little bit harder when you're subtracting because if you think 18 plus 1 is 19, 2 plus 9 is 11, 3 plus 6 is 9, you're not going to get a negative 7. But if we're subtracting, which of these pairs of numbers is 7 units apart? It's this one. So we can plug in the 2 and the 9, and then we have to decide which one should be negative. In this case, it should be the 9 that's negative. And so we've got our factorization looking like this. Good job!